Good morning, everyone. Miss Soma's here. So today, I'm going to move on with the remaining learning targets that we didn't cover this year. This video is for my 7th grade extended. Although this would be a review also for my 7th graders who already learned the surface area and volume of rectangular prisms and cylinders. So this is for all of my students and to whoever would find useful, whoever would find this video useful as well. All right, so as usual, I really don't like you using any formulas without understanding why it's like that. So let's start deriving the surface area and volume of a rectangular prism. So I pre-draw here a rectangular prism. So let's just say this is my length, my width, and my height, although I can interchange them too because I can have an orientation of this rectangular prism standing up, going on its side. So it really doesn't matter which one is your length, width, and height. Okay, so when we say surface area, that means it's the total area of all the lateral surfaces of your rectangular prism. So how many faces do we have on our rectangular prism? So we have the top, the bottom, the right side, left side, front, and back. So we have 6 total. So let's look at the area of our front face. Let's say this one is our front. Okay, so right here. So since this is a rectangle, well, we know the formula of a rectangle. It's length times width. But in this case, this width here is being labeled as height. So now the formula would be length times height. All right, and then that would be the same formula for the back of this rectangular prism because that would just be the same. So length times height. Now let's look at the right side. So the right side would be this rectangle right here, which has width and height. So the formula would be width times height. And that would be the same on the left side. So left side is also width times height. Now we also have the top, and the bottom. So let's look at the top. So the top would be a rectangle formed by the length and the width. So the formula for the area of a rectangle on the top would be length times width. And that would be the same thing for the bottom. All right, so now let's add up all our areas of the different faces of our rectangular prism. So now we call that surface area. So that would be the front and the back, LH plus LH, plus the right side and the left side, WH plus WH, and then the top and the bottom, that would be LW plus LW. Now, since these two are the same, remember our combining like terms? So we could just say 2LH, and then there are 2WH, so 2WH plus 2LWs. Then that is the formula for the surface area of a rectangular prism. And on your formula sheet, I think they have it as 2LW plus 2LH plus 2WH. And what property allows us to rearrange this? Well, it's commutative property. So we are just rearranging them. Okay, so that's the formula of the surface area of a rectangular prism. And then the volume would just be the length, the width, times the height. Okay, so let's practice some exercise. So let's say I have a rectangular prism. All right, so we have, let's say 4 centimeters, and this is going to be 3 centimeters here, and this is 2 centimeters. All right, so the surface area. Now, I would advise you to always start with the formula. I know you like to do shortcuts all the time, but let's avoid mistakes. So to avoid mistakes, I want you to always start with a formula. Surface area is 2LW plus 2LH plus 2WH. Now, at the start, assign which side would be your length, width, and height. So I would like this to be my length, my width, and my height. So you can always go back to your drawing. Or if you like, you can do it this way. Length is 4, width is 3, height is 2. Because I don't want you making mistakes of like using the width as your height as well. So now we will put it in our formula, and I know all of you have used Desmos as well. Once you put them into your formula, you could just go straight to your Desmos and put them in as it is. The length is 4, the height is 2, the width is 3, and the height is 2. All right, now when you put this in your Desmos, you do it as it is, and then you will get the answer. But since I'm not opening a Desmos here, so we're just gonna do 2 times 4 times 3. So this would be 8 times 3 is 24. 2 times 4 times 2, so 8 times 2 is 16. 2 times 3 is 6 times 2, so that would be 12. And now let's add this together. So that would be, I'm sorry, I don't have a calculator here with me. I'm gonna call my son. Hey babe, can you bring mommy calculator please? So now this would be 40 plus 12. Is that correct? Yes. So now it's 52 square centimeters. So that's the area of our surface area of a rectangular prism. And then the volume is the easy one. So just length times width times height. So now you will have 4 times 3 times 2. So now we will have 24 cubic centimeters. All right, so now let's look at what happens to the surface area of this rectangular prism if I am going to double the length. All right, so now instead of, can I have calculator please? Just let me use yours. It's on your desk. So now let's make this bigger, well, longer. It's like this now. Okay, so now instead of having a 4, we are changing the length to be 8. And then the width will stay the same, and then the height will stay the same. Okay, so now, let's put in our formula. So let me get another sheet. Thank you, baby. Let me just rip a page here, because I already have a drawing on the next page. I thought I only need 1 page. Okay, so now we have the surface area. But first, let's make a prediction. Do you think that if I double the length of my rectangular prism, so right here, I'm doubling it, do you think the surface area will also double? So let's find out if you think it will double or if you think it will not double. Okay, so 2LW, I like to always start with my formula. 2LH plus 2WH. So now 2, my length is now 8, width is the same, plus 2, 8, and then 2, plus 2, 3, 3, and then 2. All right. So now, before I'll finish solving this, I'd like you to make a comparison here. I'm gonna highlight them so that you will see what's changing. So here, it's right here, okay? And now, this right here is right here, okay? It seems to be doubling. And now this right here, oh, this is a new pen, is right here. It didn't double. So do you think the surface area will double? Okay, so it looks like it's not gonna double because only these two terms right here is doubling. So now let's finish this. So now I have my calculator. So we have 2 times 8 times, oh, this is 3. Sorry, I wrote the W. Times 3 is equal to 48. Well, I could just simply double this. So this is 32 plus 12. So obviously, it's not going to double, but we're going to find out, we're going to look at it. Why is it not doubling when I double the length? So let's see. 48, let me see. 48 plus 32 plus 12 is 92. So 92 square centimeters. Now, why is it not doubling? Because of this right here. When you look at your drawing, imagine me adding another one of these right next to it. So let me make a drawing of that. So it's gonna look like this. The original one is gonna be doubled now. So there's another one here. So you notice that there is a section here that will not be included anymore because this is already being covered by the merging of the two rectangular prisms. So that's why it's really not doubling the surface area. Okay, now we also have a lesson on percent of change. So let's take a look at that one. Okay, so the original, before doubling, the original surface area was 52 square centimeters. Now it grew to 92 square centimeters. So now let me ask you here, what is the percent of change in the increase of our surface area? So some of you develop your own formula on finding the percent of change. You can go ahead and use your own formula, but I'd like to stick to our lesson in proportion. So which one is our original number here? So the original surface area is 52. So that 52 is our 100% because that's the original. So any original value is always equal to 100%. Now this one became 92, and then let's find out how much percent is 92. So let's solve that. So 100 times 92 divided by 52. So it's really like 52x is equal to 9200. Now I can divide by 52. So divided by 52. So x is 176.92%. All right, so now we can see that from 100% it is now, so from 100% it is now 176.92%. So how much is the percent of increase? So the percent of increase is only 76.92%. All right. Now let's investigate first what happened to the volume if I double the length. Okay, so now volume would be length times width times height. So the length is now 8. The width is still 3. The height is still 2. So before it was 4 times 3 times 2. So can you tell that it doubled here? Yes, it doubled. So now from our original volume of 24, now it is 48 cubic centimeters. All right, so now let's proceed to finding the surface area and volume of cylinder. All right. Okay, so the surface area and volume of a cylinder. So what are the lateral faces that compose the cylinder? So then we have the top and bottom circles. So the top and the bottom circles. Bottom circles. Okay, so what is the area of a circle? So the area of a circle is pi r squared, and we all know that already. So then there's the top and bottom are the same circle, so there's another pi r squared. And then we also have this body of the cylinder, which when you open, it becomes a rectangle. All right, so that's the body of our cylinder. And this part right here is simply your height. And this right here, when I am going to roll this, would form a circle. Now, what do you call that part of a circle right here that tells you, it's kind of like the perimeter, that tells you how long is, if you were going to put a string here, how long would that string be to form that circle? So that's what you call circumference. So therefore, this side of the rectangle here will form the circumference of a circle. Now, what is the formula of the circumference of a circle? It's 2 pi r. Okay, so now, since this is a rectangle, so we could just multiply the length with it, which is 2 pi r, and the width, which is the height. So now the formula of this body of the cylinder is 2 pi r times h, or we could just say 2 pi r h. All right, so now let's do the surface area. So the surface area is the two circles, so that gives you 2 pi r squared, because there are two of them, plus the body, the area of the body of your cylinder, which is 2 pi r h. So there you go. That's your formula for the surface area of a cylinder. Now let's look at the volume. So I want you to imagine as if I have a bunch of circles stacked until this height here. So then the volume is just the pi r squared, which is the area of our circle. Then we multiply that by the height of the stack. So now the volume is pi r squared h. Okay, so let's practice an exercise. So let's do, I'm gonna do my cylinder going this way because I don't like you to get used that, oh, the height is always on the vertical side. All right, so let's say this is 8 centimeters. I like using centimeters. Now I'm gonna give you a diameter instead of, let's say 6 centimeters. All right, now take note that our formula is using radius, not diameter, because sometimes in the test you will see diameter instead of radius. So now let's always start with our formula. Is A is 2 pi r squared plus 2 pi r h. All right. Now I like to advise my students to always put values here first. So what is our radius? If our diameter is 6, our radius is 3. And then we need a value of height. So our height is this one here, 8 centimeters. So hint, you always find your radius on the circle. So first approach, go to the circle, look for your radius there. All right, so now in the as well, they always want you to use 3.14, okay, for pi. So now let's put it here. 3.14 times 3 squared plus 2 times 3.14 times the radius, which is 3, times the height, which is 8. Again, if you have your Desmos open, by the way, for those who are at home and does not have a calculator, you can always open Desmos and click the scientific one. So when you go to Google, you put Desmos, and then there's going to be a lot of options that will pop out, and then you click the scientific one, and then you could just simply type all these values. Okay, so now let me do it in mine. 2 times 3.14 times 3 squared. So this gives me 56.52 plus 2 times 3.14 times 3 times 8. So that gives me 150.72. All right, now let's add this together. Plus 56.52. So that gives me 207.24 square centimeters. And then let's solve for the volume. The volume is pi r squared h. So 3.14 times 3 squared times 8. All right. So 3.14 times 3 squared times 8. All right, so that gives me 226.08 cubic centimeters. Now let's investigate again. What happens to the surface area if I will double the height? Do you think that it will double the surface area as well? So again, it's the same concept as our rectangular prism. Imagine putting another cylinder here. So we see that this part of the cylinder is not going to be included in computing the surface area anymore. So now you will have surface area equals 2 pi r squared plus 2 pi rh. So 2 times 3.14, the radius is still the same. And then 3.14, 3, and then instead of having 8 as the height, we now have 16. So you see, only this part here is doubled. So then that makes the surface area not really doubled. So this would be the same value here. So that would still be 56.52. And this one here will double. So 150.72 times 2. So this gives you 301.44. And then you add them, plus 56.52 is 357.96 square centimeters. All right, so now let's determine the percent of increase from the two surface areas. So before, it was 207. So before it was 207.24. Now it grew to be 357.96. So the percent of increase, this is our original. So this is our 100%. Again, you can use whatever formula you have on finding the percent increase. So this is X. But I like to stay consistent with the proportion lesson that we had in the past. So that gives me 357.96 times 100 equals divided by 207.24. That means this is equal to 172.70%. So the increase is only 72.70%. All right? And then let's look at what happens to the volume. So if the volume is double, if the height is doubled, so let's say volume is pi r squared h. So 3.14, and the radius is 3, and then square it, and the height is now 16. So you see that it's gonna double, okay? Because we're just multiplying everything. So then that means 3.14 times 3 squared times 16 is now 452.16 cubic centimeters. So our volume here was 226. Now it doubled. Okay, so now we're gonna go to surface area and volume of a square pyramid. So in our curriculum, we only focus on the square pyramids. But the formula of square pyramids, the formula of the surface area and volume of the square pyramids also apply to a rectangular based prism. So that's why we make it as like a general formula. But again, for us, it's just going to be all square pyramids. Okay, so I look at the lateral faces of that make up the square pyramid. So we have here 4 triangles and a square on the base. Okay, so now we know the formula of an area of a triangle. So the formula of an area of a triangle is, okay, well, hold on. Let's look at the total faces first. So we have 5 together. So now the surface area of this would be the triangle 1 plus the area of triangle 2, triangle 3, triangle 4, plus the square, which is the base. Okay, so now what is the area of a triangle? So the area of a triangle is 1/2 base times height. So 1/2 of its base and times the height of that triangle. So in our case, instead of calling this height, we now call this L because this is our slanted height when we are going to form this into a square pyramid. So now that would be the first triangle. So let's say this is our first triangle, the second, the third, and the fourth. So now we will have 1/2, and then we call it base 1. In this case, we know that base 1, base 2, base 3, base 4 are all equal to each other, but I'm naming them base 1, base 2, base 3, base 4 in case we will be dealing with a rectangular based pyramid. All right, so base 1 times L. The L here are all the same. All right, plus 1/2 base 2 times L plus 1/2 base 3 times L plus 1/2 base 4 times L plus the area of the square, which is just the base. Okay, I'm just going to write the word base there. All right, now, did you see anything that is a repetition here? This is a repetition here. 1/2 is a repetition. The L is also a repetition. So we can merge this into, we're going to express it as a distributive property. So 1/2 L, and then I'm just going to add this. So base 1 plus base 2 plus base 3 plus base 4 plus the base of your square pyramid. Okay, so the area of base. Okay, now, what does this represent? So the base 1, base 2, base 3, base 4, here, this represents the perimeter of our square. So now I'm going to change this, or if you have a rectangle, so that would still represent the perimeter of your rectangle. So now we change this into perimeter. So now your formula is 1/2 LP plus B, which is the area of the base of your square pyramid. So now let me compare with our formula from the formula sheet. So now, yes, so we have 1/2 LP plus B. That's our surface area. Now, for the volume, this square-based pyramid, so normally in class, I would perform an experiment and I'm gonna have you guess how many of this square-based pyramid I would fill this up with rice or water, and I'm gonna have you guess how many of these square-based pyramid could fit into a cube. And you will see that it would require 3 of this square-based pyramid would be required to fill up the whole cube. So we need 3 of this to fill up the whole cube. So therefore, this square-based pyramid is 1/3 of the volume of your cube. So this is 1/3 of the volume of the cube. So now let's look at the cube. We already call this the base right here. So we're just multiplying it by the height. So the area of a cube is just base times height. Now, since this is 1/3 of that, so you just do 1/3 of the base times height. So that's why our formula is 1/3 of the base times height right here. So these are the 2 formulas. Now let's practice some exercise. Okay, so let me do, and how I draw my square-based pyramid is really just make a rhombus. All right, and then I just mark a point somewhere. Let's see right there. And then I connect it to all the corners. And now I have a square-based pyramid. Okay, so now I'm gonna do a length here. So let's say the length here is 8 centimeters. I like using centimeters for today. And then my square, I'm gonna make this 4 centimeters. All right, so now let's write our formula. Surface area is 1/2 LP plus B. Okay, so now again, I always make it a habit to write down the values of LP first, the P, and the B, so I won't make mistakes. So the L here, the slanted height, is 8. Now the perimeter is 4 plus a 4 plus a 4 plus a 4. So that gives you 16. Okay? And now the area of the base, since this is a square, it's just 4 times 4. So now the area of the base is 16 as well. So now we can do 1/2. Now, take note that the perimeter and the base are not always equal to each other. This is just a special case right here. The L is 8. The perimeter is 16 plus 16. So now you will have, you can put that into your Desmos or your calculator, times, how much is that? 8 times 16 is 64 plus 16 is equal to 80 square centimeters. And then our volume is 1/3 base times the height. All right, now I want you to understand here that your L is not equal to your height. Your height is always perpendicular from the vertex going down to the middle, the center of your square. So that is your height. That's how tall your square-based pyramid is. Now in this case, I didn't give the value for the H. Now, can you think of a previous lesson that you've had that can help us solve this problem? So let me draw this right here. I want you to think anything that's familiar that you've learned in the past that we can use here. Take note that this is 90 degree here. What did we form? We form a 90 degree, a right triangle. So now let's redraw our right triangle here. This is our height. Now since it hits in the middle of your square, so if the whole length is 4, so that means that is just 2. And this is 8. Oh, isn't that Pythagorean theorem? So whenever you have a right triangle, it's always, that's always Pythagorean theorem. Okay, so now we will have, this is our C here, the longest side of our triangle. So this is C. So now A squared plus B squared equals C squared. Okay. Now I would like to have H as my A. We can make this as your B as well. 2 squared is equal to 8 squared. So H squared is equal to 4 is equal to 64. Oh, sorry, this is plus. Minus 4, H squared is 60. Now take the square root of H squared. So H is, let me see, square root of 60. So 7.745. So I'm going to round it off as 7.75. Sorry. All right, so 7.75 centimeters. So I know that my height is now 7.75. In most cases, the teacher will give you the height, but in this case, I purposely not give you the height so I can show you what to do when in case the height is not given, or when they give you the height here but they didn't give you the L. So you do the same process. You just do your Pythagorean theorem. So now let's solve for the volume. So the volume is 1/3 base times height. So equals 1/3. What is our base? Our base is 16. And what is now the height of your pyramid? 7.75. So now let's do that together. So 1 divided by 3. Please don't use 0.33 for your 1/3. I'd like you to use 1/3. So 1 divided by 3 times 16 times 7.75. Again, if you're using Desmos, that will do that for you. So now I have 41.3 repeating cubic centimeters. I'm not going to do any more the percent of change because it's kind of like the same thing as before. You just kind of like double the height and then put it in your formula, or double the length, put it in your formula, or double the side and put it in the formula, and then you can compute it from there. All right, so now we are going to look at the surface area and volume of a cone. All right. See, I prepared for this lesson today. I made drawings already before starting. Okay, so the surface area and volume of our cone. So now what are the lateral surfaces of that make up our cone? So we have the circle at the bottom, and then this body here of our cone. And I made a tiny cone here. So anyway, it looks like that. So tiny. And then if you open it, it's gonna look like that. Okay? So let me make that drawing. All right, so now, oh, here it is. I already made that drawing. Okay, so again, what is the area of a circle? The area of a circle is pi r squared. Okay? Now with this is a part of your circle. So if I would have a bigger circle, this right here is a cross section of it. That's what that is. Okay, so now I'm gonna use, or again, I'm gonna always go back to our previous lesson. So how do I find the area of this cross section of a circle here? So now I have two shapes here. I have the circle and I have the area of that cone. So now we are going to do a ratio here. Okay, so now we are comparing these two. Now, what is it that we know about this already? Now, I also know the circumference of the circle. Okay, so I'm gonna compare the circumference of the circle with the circumference of the arc length right here of my cone. So I'm gonna do comparisons there. And then I'm gonna compare it with the area of the circle, compare it to the area of the cone. So I will get the formula for this area of the cone. So two things I'm gonna be comparing here, the cone and the circle. All right, so now going back to our proportion lesson, I'm gonna compare with the circumference of cone with the circumference of circle. Then the ratio here should also be equal to the ratio of the area of circle over the area of cone. Okay? And this looks familiar to you, right? Okay, so now what is the circumference of the cone? So take note that if I am going to close this right here, it will make a circle as well. Okay? So now we call this as our radius here. Okay? So now the circumference of my cone is actually the circumference of a circle here, right? Okay, so now this one is actually 2 pi r. All right, so now the circumference of a cone is actually at 2 pi r. Now, the circumference of a circle is going to be this right here. This is the radius here. But what do we call this right here? This is the slanted height of our cone. So now we call this L because the R here is not the same value as our L. R is from the cone and L is from the circle. So now the circumference of a circle is 2 pi L. And L here is longer than our R. And then what is the area of a circle? So the area of a circle is pi r squared. But we don't use r here. Our r is for our cone. So it's pi L squared. Because that's the radius of our circle there. Over the area of the cone. So by doing this is my unknown area of a cone. So now I can solve it. I know this, I know this, I know that. All right, so now I'm going to change this into an x. Okay, so what happens here? Oh, let's simplify this real quick. So 2 and 2, pi and pi. So now you end up with r over L is equal to pi L squared over x, because I don't know that. Okay, so now I end up with Rx is equal to pi L squared. Is that what it happened? All right, now hold on here. Pi okay, I made a mistake here. So 2 pi r and then 2 pi L. Oh, I made a mistake. The area of, see, I made a mistake here. I put the circle. Circle is at the bottom. And I should switch these two here. Sorry about that mistake. All right. So we have to be consistent. So circumference of a cone. So let me go to another paper here. So instead, we are going to do the circumference of a cone. I'm going to switch this because cone is on top, so cone should be on top as well. So C of cone over C of circle is equal to A of cone. There we go. Over A of circle. All right, so now circumference of cone, we had 2 pi r, all over the circumference of circle, which is 2 pi l, is equal to area of cone, which we don't know, and the area of circle is pi l squared. So now cancel, cancel. So we have r over l, x over pi l squared. Okay, so now we can multiply this together. So now we have r pi r l squared is equal to xl. Now, since I'm looking for the formula for x, I'm going to do L here. So now the formula for my x is pi RL. All right, so now we can comfortably use now the formula of given to us by the formula sheet. So now the area of a cone, surface area of a cone is from our formula. So we have the circle, which is pi r squared, plus the lateral surface area of our body of the cone, which is pi rl. And then the volume of this, so the cone is actually a cross-section of your cylinder. So now what is the volume of our cylinder? The volume of our cylinder is pi r squared h. Now, again, if we were in a classroom, I would do an experiment on how many cones could fit into a cylinder. So now you will realize that it would require 3 of this to fit into the cylinder. Therefore, the cone is 1/3. The volume of a cone is 1/3 of the volume of a cylinder. So that's why we have a formula 1/3 pi r squared h. All right. And so let's practice one exercise. So let's try having a cone this way. And the L is going to be 10. And I'm going to make the height unknown. Okay? All right. And then the radius is, let's say, 6 centimeters. All right. So did you get that? Okay. So now let's always start with the formula. Surface area is pi r squared plus pi rl. So now 3.14 times the radius, which is 6 squared, plus 3.14 times 6 times 10. All right. So let me do that on my calculator as well. So I have 3.14 times 6 squared equals 113.04 plus 3.14 times 6 times 10. That gives me 188.4 plus 113.04. That gives me 301.44 square centimeters. Okay? And now let's look at the volume. Excuse me. Okay, so for the volume, I purposely didn't do the height as well. So for the volume, you would have 1/3 pi r squared h. Okay, since I don't know the height, and this is always perpendicular to the base, we can form our right triangle again. So now, here comes a right triangle. This is unknown, but how much is the radius here? We know this is 6, and this is 10. So again, we can use our Pythagorean theorem. this time I'm gonna use this as my b. So I'm gonna have a squared plus b squared equals c squared. So now a is 6, so 6 squared plus h squared equals 10 squared. So this is 36 plus h squared equals 100 minus 36. So h squared is equal to 100 minus 36. Oh, hold on. 100 minus 36. That gives me 64. So take the square root. So my h is equal to 8. All right, so now I know that my h is 8. So 1/3 times 3.14. Sorry, I'm already too focused with my solution. All right, so now we have the radius is 6 times the height, which is 8, equals, so 1 divided by 3 times 3.14 times 6 times 8. That gives you 50.24 cubic centimeters. There you go. So I've shown you how to find the surface area and volume of rectangular prisms, cylinders, square-based pyramids, and cone. And for my 7th graders, you are most welcome to learn the surface area and volume of square-based pyramid and cone, but in our curriculum, you're only expected to learn the volume and surface area of rectangular prism and cylinders. And you can always go to Google and look for practice exercises on this unit. You can, if you know your IXL account as well, you can always log in. And if you don't know your IXL account but want to get into IXL, please shoot me an email and then I can give you your credentials. Till next time.